Hey, physics students, going to give you some notes here about energy with the mass oscillating on a spring. And then we're going to talk a little bit about trig functions and how to write the equations for these trig sine and cosine things that we are seeing happen here. That's going to be pretty easy to do. We're going to lean a little bit on stuff that you should have learned in your pre-calculus class. All right, so with energy, I'm going to just sketch my mass on spring. Give myself a lot of room here. So there's your spring, and this is the equilibrium position right here. And then I'm going to draw another position here, 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 and here. Now, and I'm going to say this is that's like my maximum position. So this would be like negative A here, right? So it's going to oscillate back and forth. And I just made these different dots so I can think about what's going on at those different positions in terms of energy. So here, maybe we should just remind ourselves of a couple things here real quick. No, actually, not yet. Just kidding. We can think about, before we remember any equations like mathematical models from Unit 8, we can just think about the pie charts. Remember our very first way of thinking about energy. Here, as it passes, as this thing goes back and forth and passes through the middle, right here, this is where the spring is at its relaxed position. So this is where there is no energy stored inside the spring. What I was thinking, I may be getting a little ahead of where we're at right now, but remember that spring energy is equal to 1/2 kx squared, and this is where the x is 0. So here, it's got all kinetic energy. We don't have to worry about gravitational potential energy because this thing is just moving back and forth. Now here, at its maximum position, this is a turnaround point. So at that spot, and also at this spot where it's turning around, those are places where the velocity is 0. So here, there's no kinetic energy because it's turning around. The velocity is just very temporarily 0 there. So here it must be all elastic energy in the spring. And then here it's some mix. I'm going to draw it like it's about half and half. It's actually not half and half. It's more EE than EK, but we don't have to get into exactly what the blend is, because this is just a qualitative. If you're thinking to yourself, wait, why is it not half and half? It's because of the x squared in there. So anyway, don't worry about that. It's all good. We do know the fact that we're going to really use here is that here in the middle it's all EK, and at the extremes it's all EE. Now if there's no friction, then there's no energy lost, so that means the total amount of energy in each pi has to be the same. So that means the EE, when we're at the maximum position, right, A or negative A, like the furthest distance from the center, must be equal to the EK when we are at x equals 0, which is when it's going to have its maximum velocity as it goes through the center. Okay, so EE, remember that EE is equal to 1/2 kx squared, and EK is equal to 1/2 mv squared. So that means here that 1/2 k times x max, but the x max is my amplitude. So 1/2 k a squared must be equal to ek 1/2 m v max squared. That is an important thing for us to know because that allows for us to figure stuff out, knowing that this is true. You can solve this for, depending on what you know, you would have to know we have 1, 2, 3, 4 different things. So if you knew 3 of those, then you could figure out the other. Usually we know what the mass of the object is, and then we might have a graph or something where we can figure something else out. So there you go. Give you an example real quick here. So let's say we're looking at position versus time for some mass oscillating on a spring. And let's say that this maximum position right here is 0.05. This is measured in meters. Right? And say we also know that the period here, the time that it takes to go through one full cycle, is, let's just make it 1 second. And probably we know what the mass of the object is, so let's make the mass equal to, how about 0.25 kilograms. All right, so that's interesting. What do we know and what can we figure out here? So the two things that I do know that with this period here, the only equation that I have that uses the period in it is period is equal to 2 pi times the square root of m over k. I know that. That came in our last set of notes. And here, I know what the period is, it's 1 second, and I know what the mass is, it's 0.25. So I can figure out what the k is by doing a little algebra with this. I'm going to do that in a second. And if I do that, if I can figure out what the k is, then I know what the k is, I know what the amplitude is, and I know what the mass is, so I can figure out what the Vmax is from there. Now that's pretty cool. So that's what we're going to try to do. So the period here is equal to 1, is equal to 2 pi times the square root of m 0.25 over k. Now, depending on your calculator skills and your algebra skills, there's maybe different ways that you would want to deal with this. I got pretty good algebra skills, so I'll show you what I'm going to do. I'm going to square both sides. So I'm going to square the 1, which is still 1. I'm going to square this side, which means I have to square all of the bits, because I want to try to get rid of that square root sign. 2 squared is 4. Pi squared is pi squared, whatever that is. And then I'm squaring this, so the square root sign goes away. So times 0.25, all divided by k. If you're like, wait, how did the k get under everything? That's because multiplication and division work that way. That means the same thing as if I had just written it like that. Surprise, that's math. And then I'm going to multiply both sides by k to move it up here, k times 1. If there was another number here besides 1, I'd have to divide that over here. So k is going to be equal to whatever 4 pi squared times 0.25 is. So that's about, I don't know, that's about 10. Let me grab a calculator real quick. Hold on, coming back. Getting a calculator. Got one. Typing in pi squared. That's about 9 point, let's call it 9.9. 9.9 newtons per meter after mathing that. And then now that we know that, I can also find my Vmax. So another little math problem here. So I know that 1/2 the K I now know is 9.9 times the amplitude, that's like the size of the oscillations, that's 0.05 squared, is equal to 1/2 times the mass of this thing is 0.25 times Vmax squared. And that's what I'm going to try to find. Okay, so I just have to do a little bit of math here. The 1/2s cancel out. I can just multiply both sides by 2 or divide by 1/2, however you think about that. When you think about things like that. So now I've got 9.9 times 0.05 squared, and then I'm going to divide by 0.25. That's what Vmax squared is equal to. So then I'm going to just take the square root of that number and get that the Vmax is equal to 0.31 meters per second. So that's the kind of thing that we can do. It does get a little heavy in the algebra, I guess, but that's what happens in physics class. So speaking of getting heavy in the algebra, what if we wanted to write the equation for one of these trig functions? Just going to remind you what you need. We're not going to deal with any horizontal or vertical shifts. Well, that's good news. Here's what you need to know. You need to know the shapes of the four basic trig functions. So sine looks like this. It starts here and then goes up. And so if that's the sine function, negative sine is just that, but upside down. Upside down? Upside down? And cosine, that's the one we usually use for position because it starts at the max position. And then negative cosine is the upside down of that. Right? How do you write the equation for one of these things? Well, if you know, I'm going to call this t, right? That's our period, the amount of time it takes to go through one full cycle, and you also know here the amplitude. Then the way that you write the equation for one of these things, the equation for this would be, now I'm going to assume that these are position graphs, but you could do the same thing for velocity or acceleration, right? We don't want to default into y equals x stuff. If it's position, then I'm going to call it x equals, and the amplitude comes first, then whichever one of the four trig functions you think it is. This one's a sine function. And then here on the inside is the number that goes here is 2 pi divided by the period times t. Two pi divided by the period. Why is that true? That's a pre-calc thing. You know, I could go into a whole thing about that, but I don't think it's just not that important for us why that's true. It's because if you measure angles in radians and then the period is, you know, whatever. It doesn't matter. For us, we just need to know that that's true. So for this one, because it's negative sine, I would make that negative a sine, and then the number that shows up here would be 2 pi divided by whatever the period is, times t. Hopefully from pre-calc that rings a bell. If you want to know more about why that's true, you could ask me. We could talk about it. But I'm going to say unit circle things, so if you don't want to hear me talking about the unit circle, then probably shouldn't ask me. So they all look the same. It's just a matter of putting the amplitude here, the 2 pi over t, whatever number that is, inside here. You would divide that out with your calculator. For example, if the period was like, what was it from our last example? The period was 1, so I'd actually do like 2 pi divided by 1. I'd actually put that number in here. And that's, I think, that all you need to know. It's also important to know that if you're given the equation, like whether it's position or velocity, doesn't matter. Like position is equal to a cosine, and then there's just some number here. In pre-calc class that was usually listed as b. Then, just like this is 2 pi over t, then the period is equal to 2 pi divided by whatever number that is. If you're wondering how magically it's the same thing whether you're going this way or that way, it's because they're inverses of each other, and when you multiply, you can like cross multiply, swap the places of those. So that's also because of math, and that's off your screen. Sorry about that. So let me just run through that again. So if you're given this, and you want to know what the period is, then the period's just 2 pi divided by that number. If you know the period, then this number is 2 pi divided by the period. If you know this number, then the period is equal to 2 pi divided by that number. So either way, it's 2 pi divided by the other one is the other one. So that's nice. Kind of hard to mess that up. All right, that should do it.